Electrical systems, while providing essential power, can present significant hazards if not properly installed, maintained, and inspected. Over time, experience can lead to a sense of familiarity, but it's crucial to remain vigilant, as unexpected situations can always arise. One area of concern is the improper support of electrical components, particularly circuit breakers. Circuit breakers are designed to protect electrical circuits from overcurrents and short circuits. They must be securely mounted to ensure proper operation and prevent accidental disconnections. When circuit breakers are installed without adequate support on the load side, the weight of the conductors and any connected devices can place excessive stress on the breaker's terminals and housing. This stress can lead to loose connections, overheating, and ultimately, failure of the circuit breaker. In extreme cases, unsupported circuit breakers can even detach from the electrical panel, creating a dangerous situation. The connection of the circuit breaker to the busbar is also vital to consider. The busbar serves as the main power distribution point within the electrical panel, and a secure, properly taut connection between the circuit breaker and the busbar is essential for reliable power delivery. A loose or corroded connection can create resistance, leading to heat buildup and potential arcing. Arcing can ignite nearby combustible materials and cause a fire. The integrity of the transformer is another critical aspect of electrical safety. Transformers are used to step down or step up voltage levels to match the requirements of different electrical equipment. They are typically housed in enclosures to protect them from environmental factors and prevent accidental contact with energized parts. However, transformers can also be dust magnets, attracting dirt, debris, and other contaminants over time. The accumulation of dust and debris on the transformer's surface can impede heat dissipation, causing the transformer to overheat. Overheating can degrade the transformer's insulation, reducing its efficiency and lifespan. In severe cases, overheating can lead to transformer failure and even fire. Regular cleaning and maintenance of transformers are essential to ensure their safe and reliable operation. This includes removing dust and debris from the transformer's surface, inspecting the insulation for signs of damage, and verifying the integrity of the connections. The location of electrical equipment is also an important consideration. Transformers should be installed in well-ventilated areas to allow for proper heat dissipation. They should also be protected from moisture, corrosive fumes, and other environmental hazards. Installing transformers in areas with high dust levels can exacerbate the problem of dust accumulation and increase the risk of overheating. Laundromats, with their dryers producing lint and dust, can be particularly challenging environments for transformers. In such environments, it is even more important to implement a robust maintenance program to prevent dust buildup and ensure proper ventilation. Electrical metallic tubing, or IMT, is a common type of electrical conduit used to protect wiring in buildings. It is a lightweight, rigid steel tubing that is easy to install and provides excellent protection against physical damage. EMT is typically connected using fittings that are either compression type or set screw type. Compression fittings provide a watertight seal and are generally preferred for outdoor or wet locations. Set screw fittings are less expensive but may not provide as good of a seal. When installing EMT, it is important to properly support the conduit to prevent it from sagging or bending. Support should be installed at intervals specified by the National Electrical Code, or NEC, and should be securely fastened to the building structure. Improperly supported EMT can be damaged, exposing the wiring inside and creating a safety hazard. Flexible metal conduit, or FMC, is another type of electrical conduit that is often used in situations where flexibility is required. FMC is a spiral wound metal conduit that can be easily bent and flexed. It is commonly used to connect electrical equipment to junction boxes or to run wiring through tight spaces. FMC is not as strong as EMT and should be protected from physical damage. When installing FMC, it is important to use the correct type of fittings and to properly support the conduit. The National Electrical Code, or NEC, is a comprehensive set of standards for electrical installations in the United States. It provides detailed requirements for wiring, grounding, overcurrent protection, and other aspects of electrical safety. The NEC is updated every 3 years to reflect changes in technology and best practices. It is essential for electricians and other electrical professionals to be familiar with the NEC and to follow its requirements when installing and maintaining electrical systems. Grounding is a critical aspect of electrical safety. It provides a low impedance path for fault current to flow back to the source, tripping the circuit breaker or fuse and preventing electrical shock. Grounding systems must be properly designed and installed to be effective. Grounding electrodes, such as ground rods or ground plates, must be installed in accordance with the NEC. Grounding conductors must be properly sized and connected to all metal enclosures and equipment. The neutral conductor is also an important part of the grounding system. It provides a return path for normal current flow and is also used to ground the electrical system. The neutral conductor must be properly sized and connected to the grounding electrode. Overcurrent protection is another essential aspect of electrical safety. It protects electrical circuits from overloads and short circuits. Overcurrent protection devices such as circuit breakers and fuses are designed to interrupt the flow of current when it exceeds a safe level. Circuit breakers are resettable devices that can be tripped manually or automatically. Fuses are one-time devices that must be replaced after they have blown. The selection of the proper overcurrent protection device is critical for electrical safety. The device must be sized to protect the circuit from overloads and short circuits without nuisance tripping. The NEC provides detailed requirements for the selection of overcurrent protection devices. Wiring is the backbone of any electrical system. It carries electrical current from the source to the various loads. Wiring must be properly sized to handle the expected current flow without overheating. The NEC provides tables that specify the allowable ampacity of different types of wire. Wiring must also be properly insulated to prevent electrical shock. The type of insulation used depends on the application and the environment. Wiring must be installed in accordance with the NEC. It must be properly supported, protected from physical damage, and terminated at approved enclosures. The electrical panels are the central distribution points for electrical power in buildings. They contain circuit breakers or fuses that protect individual circuits. Electrical panels must be properly sized to accommodate the expected load. They must also be properly grounded and bonded. Electrical panels should be inspected regularly for signs of damage or overheating. Any loose connections or corroded components should be repaired or replaced immediately. Electrical equipment should be inspected regularly for signs of wear and tear. Any damaged or malfunctioning equipment should be repaired or replaced immediately. Regular maintenance is essential for ensuring the safe and reliable operation of electrical systems. This includes cleaning equipment, tightening connections, and testing overcurrent protection devices. Electrical work should only be performed by qualified electricians. The electricians have the training and experience necessary to safely install, maintain, and repair electrical systems. They are also familiar with the NEC and other applicable codes and standards. When hiring an electrician, it is important to check their credentials and ensure that they are licensed and insured. A permit is typically required for electrical work. The permit ensures that the work is inspected by a qualified electrical inspector. The electrical inspector will verify that the work is performed in accordance with the NEC and other applicable codes and standards. Ignoring these basic principles can lead to serious consequences, including electrical shock, fire, and property damage. Always prioritize safety and consult with qualified professionals when dealing with electrical systems. In conclusion, maintaining electrical safety requires vigilance, knowledge, and adherence to established codes and standards. From properly supporting circuit breakers to ensuring clean and well-ventilated transformer installations, every detail plays a crucial role in preventing hazards and ensuring the reliable operation of electrical systems. Regular inspections, proactive maintenance, and the involvement of qualified electricians are essential for creating a safe electrical environment.